Okay, so why did I go through all of that, those easy peasy things? Well, it's because it's because um, I can use that to solve equations like these. Okay, so let's solve x squared plus 4x plus 1 equals 0. Well, your first inclination might be, okay, I'm going to factor that puppy because the Bexter said that I could factor a quadratic into the product of two binomials, and then I can use the null factor law. But if you look at this closer, there are no factors of 1 that will combine to give me 4. Oh man! So this method is out. But if I could manipulate this to look like something like this, wouldn't that be just great? That was so easy to solve, if you remember. I just took the square root of both sides. I was done in like 2 seconds. Well, that method is called, oops, it's not there. It's called completing the square. I'll just write it out. Completing the square. And that comes in so handy sometimes, especially when something isn't factorable. Particularly when something isn't factorable like this. It's a nice little tool to have. Well, how do you do that? Well, first thing you do, leave a little space here because we're going to do a little something something there. We're going to move that positive 1, which we call the constant, the c term, over to the right side of the equation. Okay. So I haven't changed the value, I just moved it over. In order to complete the square, what I need to have is a perfect square trinomial. Well, what is that? Well, I'm going to show you. Just hold on to your socks for a second. Well, in order to make this left side a perfect square trinomial, don't worry about the right side for now, but in order to make this a perfect square trinomial, I take 1/2 of coefficient of x term and square it. So that would be half of the coefficient 4 of the x term is 2. 1/2 of 4 is 2. And if I square 2, I get 4. So I'm going to write 4 right there. It's just a coincidence that both of these are 4. Now, I have to be concerned about the right side of the equation because right now I don't have anything equivalent, but what you have to understand is everything's cool as long as what you do to one side of the equation you also do to the other. So since I added 4 here, I have to add 4 over here. Okay, so remember I talked about perfect square trinomial. Well, guess what? Oops, I kind of butchered that. Well, tough darts. We now have a perfect square trinomial. Why is it a perfect square trinomial? Because I can factor this into x plus 2 times x plus 2, which can be written as x plus 2 squared. Hence the name perfect square, because I can write it as something squared, and trinomial because it has 3 terms. Because x plus 2 times x plus 2 can be written as x plus 2 squared. And so I'm going to simplify the right. Negative 1 plus 4 is 3. Negative 1 plus 4 is 3. And lo and behold, we are in the same form as we are here. I can take the square root of both sides. And don't forget, I don't want to get anybody in trouble, to put your plus or minus there. The square root of anything squared is the anything. In this case, the anything is x plus 2. So now x plus 2 equals plus or minus root 3. So therefore x equals negative 2 plus or minus root 3. And we have solved that quadratic by completing the square. Cool beans, I know. Okay. So again, the rules. I take half of coefficient of the x term. Half of 4 was 2. I squared it. 2 squared is 4, and I added the 4. And what I do to one side, I must do to the other. And then that will always, always, always give you this wonderful situation where you can factor it into a perfect square, or it makes it a perfect square trinomial, and it will always factor into a binomial squared. That's what makes it so wonderful, because those are really easy to solve.